Hello, Mom over here, and welcome to Module 7. This is the last of our Earth's Resources series. We have already discussed minerals and rocks, water, energy resources, and now we will focus on soil resources. For this module's learning objectives, we will identify human activities such as farming, construction of structures, and waste disposal that affect the quality and quantity of soil, and will also give ways of conserving and protecting the soil for future generations. Now, before we go ahead and accomplish our learning objective, we also need to familiarize ourselves with what soil is. Soil is something that you think you already know what it is, but there's actually more to discover about it. So soil, it consists of matter in three states: solid, liquid, and gas. The solid component consists of a mixture in mineral grains plus material of biologic origin. So this is something that I would like to highlight. Before you classify a loose earth material as soil, it must also contain decaying organisms, dead leaves, or microorganisms, because it should contain anything of biologic origin or organic. This means soil is only located on planet Earth. There is no soil in Mercury, Venus, and Mars because the only planet that we know with biologic origin is Earth. Okay, so again, soil is a product of weathering processes, and it is a medium capable of supporting plant growth. So in order for a material to be categorized as soil, it must be able to support plants and trees. Okay, so that's for the soil or solid part. Now, the water itself is also an important component of soil. We have discussed in the previous module about the hydrologic cycle. So we know that some water is contained within our soil due to infiltration. The water in the soil is full of minerals, nutrients, and important vitamins because the soil moisture has the dissolved substances, and it's important as well for supporting plants. The nutrients and moisture in the soil will allow the plants to grow. Aside from the solid and water components, it also contains some gas components. So we know that the soil itself is a loose material, meaning it's not completely compacted like some rocks. Therefore, it will allow spaces to contain carbon dioxide, methane, and oxygen. Those are also important for plant and microorganism growth. Okay, so these are a couple of terms that you might encounter if you're studying the soil science. So soil texture refers to the proportion of particles that fall into each of the three size ranges, namely clay, silt, and sand. So there are different types of soil based on the particles they contain, and we classify those particles based on their sizes. So if you look at the diagram on the left, for example, sand has 0.1 millimeters in diameter. So that would create a sandy soil. If it has majority of silt, which is 0.01 in diameter, then it's a silty soil. And if it's mostly clay, then it's considered as clay rich. So aside from the particles themselves, of course, the biological origin is the humus. So these are partially decayed organic material in soil critical to soil fertility. So whenever you hear the term in Filipino, mataba yung lupa, it means there is a large amount of organic matter, and those organic matter has the nutrients that would support the next generation of plants and trees. Okay, so if you are a ambitious plantita, you might want to look for the proper soil texture for your plants, because some plants will grow more successfully if they are in certain soil texture. And this is what the soil texture meaning. So if you're like looking online, if you want to buy some soil, and then you will see that there are different types of soil, this is what we are referring to. There are different concentrations of materials based on the particle size. So for example, if there's a high concentration of clay, then that's like considered as clay. If there's like 70% silt, okay, 70% silt, and then 60%, no, sorry, like 30%, 70% silt and then 30% clay, then that's considered as silty clay loam. So that's how you use a soil texture triangle. Don't worry, you don't have to memorize this. I'm just showing you like how we classify our soil textures. So this is a useful tool for our scientists to identify the type of soil based on the composition. Okay, so the other ways we classify or describe, the other ways that we describe our soil are these. So soil depth, so where did you get your sample from relative to the surface where there are a lot of organic matter, or is it near to the water table or the bedrock? So depending where you get the soil, it will have its own characteristics, which we will be discussing later. Next, soil texture, so we discussed that in the previous slide. And then soil structure, so the shape and size of the soil aggregates. Okay, and the shape and size of the materials of the soil will also dictate the distribution of pores or the areas where water and gases may accumulate. Organic matter, so the amount of organic matter within our soil. So if there is high organic matter component, then that is a good candidate for fertile agriculture. So those are some of the things that we have to look out for if we are propagating good soil management. Okay, so I have mentioned soil depth in this slide. So this is what we are talking about when we are discussing soil depth. So soil profile is the sequence of soil horizons from the surface down to the underlying bedrock. So soil profile is all of this. Let's find the marker. Yeah, all of this. So the sequence of soil that is present in a certain location. So you have different layers, and the collective term for those layers are the soil profile. So it varies depending on certain locations, and that is something that you have to look for if you want to survey a location for construction or agricultural purposes. Now, the soil horizon is the term for each layer, and as you can see, they actually have their own characteristics. So they have their distinct physical, chemical, and biological characteristics. So let's go through them one by one. So when we say O horizon, this is on the surface where we walk on generally. So contains the accumulation of organic matter. So this is where plants, trees are usually located, and it's quite shallow because it's only 0 to 2 inches in depth. When we say the A horizon, this is after 2 inches, is 2 to 10 inches. This is typically dark in color because of the humus present. So whenever we are digging up in order to plant seeds, trees, this is where we usually put them, in the A horizon. If you go deeper, you might find a E horizon. So this is a pale layer that is sometimes present in forest areas. It is not indicated in this slide because there's no E horizon in this diagram right here. But E horizons are locations where there's not much nutrients because, as we have mentioned in the hydrologic cycle, water infiltrates from the surface downwards into the water table. So what happens in the E horizon, the materials within the E horizon get washed up and then moves to the other horizon or soil horizons. Okay, let's click next. Next, the B horizon is brownish or reddish because of the presence of iron hydroxides that has leached from the surface. This is called the zone of accumulation. So heavy components or heavy materials from the surface may be washed or dissolved from the surface because of the infiltration, and they will stay here in the B horizon. They are reddish because, yeah, the iron components from the other horizons on top may deposit here in the B horizon. And then finally, we have your C horizon. So this area is called the subsoil. It is made up of the parent material underneath, which is called the bedrock, and is various stages of weathering. So that's why it's demonstrated as having large components here and some small components, because even if this is completely underground, it is still subject to weathering because of water and pressure underneath the earth. But the sea horizon used to be part of the solid underweathered rock underneath, and that's called the bedrock. So, flashback to the Minecraft Minecraft days wherein you dig downwards and then you will hit a certain bedrock. That's actually quite accurate, because if you dig down enough, you will reach a certain point where there is no more soil and just solid unweathered rock. Okay, so this is what it looks like in real life though. So you have your O horizon where our plants are growing. You have your A horizon where it's very dark because of the organic materials that are decaying within it. Your E horizon have concentrated amounts of quartz and silicates. That's why they're light in color and don't have much nutrients and other heavy materials. Okay, so all of the heavy materials from here will be deposited in the B horizon. So it's darker and reddish sometimes. And then finally, you have your C horizon, which contains partly weathered materials from the bedrock. Okay, so we are not showing the bedrock in this picture. So the collective horizons again is called a soil profile. So this is considered a mature soil profile because you have layers which undergone different levels of weathering. It contains humus and is able to support plant growth. So that's a mature soil profile. Okay, now that you already know what soil is and what are the things underneath the soil, let's talk about soil quality. So when we say soil quality, this is the capacity of a soil to function within ecosystem and land use boundaries to sustain biological productivity, maintain environmental quality, and promote plant and animal health. So whenever we are talking about soil, it's not just the soil itself being present, because we use soil in order to support plant growth, either in the natural world or for us human beings to provide the food for the ever increasing population of the world. So in order for a soil to be classified as quality soil, it must be able to support our agricultural needs. So there are certain activities, human activities, that might deplete the soil quality. So bad practices with farming, urbanization, and waste disposal can greatly affect the soil quality. So why do we care about the soil so much? So let's focus here on the column 2 of our slide, and you will see that this is how we use our lands. So 50% of the global habitable land, so meaning there is no ice and there's no desert, so there could be forests, urban areas, shrubs, and other fresh water is indicated here. But 50% of the world or the land on earth is used for agriculture. So 50% of our lands are used for agriculture just to support our demand for food. The rest are natural environments or urban locations. So if you can imagine, forests, there are more lands for There are more lands for agriculture than there are for forests and urban areas in collective. There are more locations just for agriculture because that's how much food we need. We are a big population. So in order to support that, we need a lot of quality soil. So in order to keep and support our ever-growing population, we have to maintain our soil quality. That's why soil is very important. There are some activities that may affect the soil itself. So, for example, soil pollution, mixing things in the soil that shouldn't be there, like plastics, trash in general. So, of course, that would affect the soil quality. So, that's a no-no. Erosion, so this occurs when soil particles are detached, transported, and deposited. Although this may occur naturally, removal of plants and trees from the soil may lead to accelerated erosion. So erosion itself is a normal part of geomorphic process. It's a natural part of the earth. But since there is a lot of human activities, we detach plants and trees in order to convert them into more agricultural land or urban areas, then that might lead to further erosion. Next, desertification. So instead of taking care of the soil and making sure that it will be good for further agricultural use, the quality of the soil may degrade. So this is possible in areas where it's arid, so quite hot climates. The moisture of the soil will be taken up either because of human activity or bad farming practices, and then the soil will desertify, will become basically a desert. So you cannot use that anymore for further vegetation. Okay, you may also accidentally acidify the soil. So this occurs when cations like hydrogen, aluminum, iron, and manganese are concentrated in the soil. So because of weathering processes, this might occur naturally that some soil may become acidic, but because of excessive use of fertilizers to increase the growth, like the production of food, because there is a high demand of food and for profit, of course, we might use certain harmful fertilizers, so like anhydrous ammonia. So if those mixes into the soil, eventually the soil itself will become acidic, and you can no longer use that after a while. So using fertilizer may be a benefit in the short run because you will have faster growing crops, and of course bigger profit. But eventually, because the soil is so acidic, you cannot grow plants anymore. So what now? Okay. Next, salinization. So this is the buildup of soil on the soil surface. This affects the physical soil quality and hinders the growth of plants. Salinization may also occur naturally. This occurs sometimes in estuaries. These are locations where fresh water meets salt water. So the soil in those locations may have high concentration of salt, but plants don't like salt. They don't grow well when you mix salt into the soil. So if we dump salt in locations where there shouldn't be salt, then it will eventually hinder plant growth. So if you're thinking, why can't we use salt water for irrigation? No, we can only use fresh water for irrigation because plants don't like salt water. Okay, so if ever that there will be a buildup of salt, then we can't use that area anymore for farming. Next, deforestation. So if you acidify or salinize a location, then that would result to further deforestation. Next, heavy metal contamination. So toxic effect on soil microorganisms and plants. Okay, so heavy metals due to Bad mining practices may accumulate in the soil. So this is present usually in urban locations because the location is heavily urbanized. There is now heavy metals within the soil itself. So sometimes the plants don't die because it may be present in low concentrations, but what will happen is the plant itself will take up the heavy metals. So meaning if the animal or human beings eat that plant, then we contaminate ourselves with heavy metal, which will eventually cause diseases and complications in our health. So that's one of the dangers of industrialization. If we don't compartmentalize or dispose of our wastes properly, then it might lead to heavy metal contamination, and that will eventually affect us, human beings, because we are the final apex predators. So if the cow eat a contaminated plant, the cow is now contaminated, and then we eat the cow. Thus, us will be contaminated. So aside from that, the heavy metal may also be mixed into the water table. Remember, water infiltrates the soil itself. So whatever material is within our soil will be mixed into our water, which we use, fresh water, which we heavily use. So chemicals and other toxins will be mixed into the water itself. Next, and finally, is another effect of agriculture is eutrophication. So this occurs when excessive amounts of nitrogen and phosphorus because of synthetic fertilizers accumulates in land and aquatic systems. So excessive nutrients in the soil is called eutrophication. So sometimes what happens is because there is a large amount of nitrogen in the water, because again, what the soil will is the moisture in the soil will be part of the water table, and that might reach our oceans, and there will be a large amount of nitrogen in our oceans. If that happens, there will be a boost in the algae population, and because there is a lot of algae, they take up the oxygen in water, and the oxygen in the water will be depleted, and that kills off fishes and our corals. So it's like a domino effect, if you can see. So bad farming practices, excessive nutrients in the soil also pollutes our water, affects the algae, kills the fishes and other marine life. So we should be very careful of how we treat our soil, because whatever we mix into the soil will affect the rest of the environment. Remember as well that soil is a semi-non-renewable resource. There is an excessive amount of soil. There is still a lot of rock on Earth that may be processed through weathering and have organic materials. But soil manufacturing, the natural soil manufacturing, takes a very long time for water and nutrients to accumulate within it. So even if we have it in excess, the natural production of soil takes a very long time. So if we don't take care of it, then we might run out of agricultural lands that will support our growing population. Okay, so this is where I will stop my lecture. We have already covered the objective number 1, but we will leave objective number 2 to be achieved through an activity. That's all for module 7. If you have any more questions or clarifications, you know how to reach me, Messenger or Microsoft Teams. Stay safe. Bye.